Hello, Matt Davis here with more homework quiz help. This one comes from section 3.4. An intermediate algebra class completed a chapter quiz using an online homework system. The time in minutes spent by each of the 18 students on the assignment is shown below. We only wish to summarize the times for these students. They give us the data, they give us the sum of an x squared, and they ask what percentage of the data values lie within 2 standard deviations of the mean. Round your answer using 2 decimal places. Don't type in the percentage symbol in the box. All right, so first of all, we're going to make some changes in the interest of giving help rather than answers. So one of those changes is we're going to reduce the data set. We're going to get rid of that last number so that instead of 18 students, we have 17. So that's one of the things we're going to change. And then instead of asking the question what percent lie within 2 standard deviations, we're going to do what percent lies within 1.5 standard deviations. The work will be the same, just a different number plugged into the formula as we go along. All right, so let's go ahead and start working on this now. We're going to actually have to work on several problems to get this one done. There's problems ahead of this one that ask us what are the appropriate symbols for the mean and standard deviation and what are the mean and standard deviation. And we really can't do any of the work for this question without those. So first, as far as the symbols go, they tell us that they only wish to summarize the times for these students. So what they're saying there is that these students are the population of interest. We're not trying to use this as a sample for some bigger population. This is our population. So if this is our population, then the mean will be mu and the standard deviation will be sigma. So that's the symbols, and now we want to go find those. It doesn't say how to find them here because that was a previous question. I believe on those questions that ask you to find the mean and standard deviation, it tells you that you can use technology. But there's a clue for that right here anyway. They don't give us the sum of the x squareds unless they expect us to use that as a check of our data entry, and that implies that we are using technology to do the problem. This particular sum is not going to match the one we get because we removed one of the data values, but normally it would. So let's go ahead and start looking at that calculator process. So what we want to do is enter all the data into the calculator into list 1, and then we want to choose stat, go to the calc menu, choose one variable statistics, and then tell it that our data is in list 1. So let's see what that looks like. So if we go over to the calculator, first we'd want to enter our data. So we hit the stat key and edit, and I've already entered all the data. So there it is. And then from there, you can go straight to starting your calculation. So what we want to do is just go ahead and press the stat key again, but now we want to do calculations. So we're doing stat, calc. This is the thing we wrote down before we came here. Top choice, one variable statistics. Our data is in L1, so second and L1. So one variable stats, L1. And we get several things there. We get a sample mean, 34.47. We get the sum of the x squareds, which we would use to check our data entry. Again, this number doesn't match the one given because we got rid of one of the data values. And they give us 2 versions of the standard deviation, sample and population, and they also give us the sample size. So forget about all that talk about sample size because this is population data. So that's really capital N of 17 down there at the bottom. And it says X bar, but it added all the data together and divided by 17. That's also how you get mu. So we have to be kind of smarter than the calculator here. We have to know the data we're working with is actually population data. So when they tell us X bar, we have to go, no, this is population data. So that's mu. And they give us the choice of S and sigma, and we have to say, we know this is population data, so we're going to choose sigma. So let's take those numbers, the X bar, which we'll call mu, and the sigma, and write them down back on that previous page. So for the mu, we take the X bar number, which was 34.47, and we take the sigma number, 10.645. I believe they asked us on the previous question for 2 decimals on the mean and 5 significant figures on the standard deviation. So that's what I put. Let's look at the calculator again, just talk about that rounding. For the X bar, it's 34.47 followed by a 0, so we don't round up, we stick with the 7. For the sigma, it's 10.644, but the 4 is followed by a 6, and that's why we rounded that second 4 up to a 5 and put 10.645. All right, so there's all the precursor work to get all the pieces we need. Now we need to get at the real question of this problem, which is what percentage of the data lies within 1.5 standard deviations of the mean. So to do that, we need to take the mean and add and subtract 1.5 standard deviations. If they asked you for 1, you'd put a 1 instead of the 1.5. If they asked you for a 2, you'd put a 2 instead of the 1.5. But we're going to calculate that to figure out what the boundaries are so that we can look at what percentage of our data set lies between those. So we take mu, 34.47. We add and subtract 1.5 times the standard deviation, which was 10.645. And then we do that calculation with the minus, and we do that calculation with the plus, and that's going to get us our two boundaries. So hopping back over to the calculator, let's clear that and get it out of the way. 34.47 minus 1.5 times 10.645 gives us our lower boundary. And then if we hit second key and enter, it pulls that up. And instead of typing it all again, we can just use the arrows to move over that minus sign and change it to a plus, press enter, and get our other boundary. So it's a nice little calculator trick to save you a little bit of time. And then going back and writing those down, we got 18.5025 for the minus side, and we got 50.4375 for the plus side. I'm just going to check real quick and make sure that was a 7. Yeah, okay. So now what does that really mean? There's only whole numbers in our table, so what we're really looking at is wanting to find things that are bigger than 18.5, so the smallest possibility that would fit that would be 19, and smaller than 50.4, so the biggest possibility that would fit that would be 50. So we're going to go in there and count anybody that falls in the 19 to 50 range, and we're going to see that's almost everybody. So I'm going to do this the quick way for you. These two right here, those are the only ones that aren't in the 19 to 50 range. You can scan through all the rest of them real quick in your eyes, and you'll see, yep, all these yellow ones, these all fall into the 19 to 50 range. So we want the yellow ones. We don't want those two green ones. Maybe it didn't color match that so well here. Let's switch this to yellow. All right, so now let's calculate what they asked for, which is the percentage. So how many fell into the 19 to 50 range? All the yellow ones, not the two green ones. So out of the, how many did we have? We had 17 people. So 15 out of those 17 fell in between those two boundaries. So we go do 15 out of 17 as a decimal. So just 15 divided by 17. We get 0.8823, but the 3 is followed by a 5, so we'll round the 3 up. So 0.8824. And then they want the percentage, so we multiply by 100%, which moves the decimal over 2 spots and adds the percentage symbol on there. So there's our answer. If I was doing it on a test, this is what I would write. But here in active learning, they said don't write the percentage symbol in the box. So we're just going to write 88.24. All right, so there's your full process. We had to decide whether we had sample or population data, calculate the mean and standard deviation, calculate the boundaries for mu plus or minus 1.5 standard deviations, and then count how many things fell between those boundaries. It was 15 of them, and then turn that into a percentage by dividing by the number of data values, which was 17. That actually gave us the decimal, and we converted that to a percentage. So I had kind of pre-counted this and knew which two didn't fit and which that all the other ones did. One of the common mistakes is just to miss a number when you're doing this. So one thing that can help is sorting your data set. So if we go over to the calculator and we hit stat and sort A, that first choice, and then we can tell it we want it to sort list 1 for us, That will put the data in ascending order from small to large. And if I go back into stat and edit, the data is in order. So we can see the biggest value is 50. That fit in the range that we wanted. When we scroll up, it's all in order. So which ones fell below 19? Well, there's the 22. It's in there. And there's the two values I said were not, the 12 and the 13. So if you sort your data set, that makes it a little quicker to see which values are in the range you want and which ones you don't. Which ones are in and which ones are not. And it makes it less likely that you'll make a mistake in the counting if you're using a sorted list. All right, I hope somewhere in there you found the part that was giving you trouble and that you're more confident and ready to head back to that quiz. So good luck to you as you do.